Today my focus will be on teaching, as I will talk about our a way that we approached problem solving in the school where I teach, together with a professor making a study on this, and together with a couple of other reflected teachers. So what is that math? People used to say that math is maths. And I use the word math because we have stopped using numeracy in Denmark a lot. It's always connected with numeracy. So therefore, I keep saying math because that's the word we use. But it is mainly numeracy. It's not a lot of abstract algebra. It is mainly numeracy. So that math actually has another nature than when math is taught in compulsory school, that it has a strong focus on the use of it, that it has a strong focus of solving practical problems, that it works with transfer between the classroom and the real world. And then, the most important thing, it is all the time disturbed by reality. We wanted the students to get deeper into the mathematics. We wanted them to talk quite a lot more about the mathematics. We have one of the experts in Denmark who do lots of studies about teaching, especially innumerates. She keeps repeating, the math you can say is the math you can do. So you need to have quite a lot more dialogue. You need to talk quite a lot more about what your calculations are. And the teacher hasn't got that much time to talk with every single student, so therefore they have to talk with each other. And also we thought, as I said, that the students can come up with some tricks and routines to calculate lots of exercises without really understanding the maths. But when they have to design, to write down the exercise, to come up with the exercise, to identify the math and to turn it into a mathematical exercise, that is when they have to have understood the math they use. Now then we thought, when that is where the teaching would be more efficient, then why is it also always the teacher who does that? Because we're supposed to be quite good at math already. So we should make the students do that, so they can learn from that on a higher, deeper level and with a bigger understanding. Then we have this one that I thought is very interesting. It's actually from a school book. The student who brought this in had a colleague who had been on a short-term labor market course, and he had this exercise there. And the funny thing about it is that on their level, they have no mathematical model for this shape, for this volume, because the two trapezes, they are not, you call it congruent, they don't cover each other. The angles are not the same, because the parallel sides are the same measure, but the depth is different. So they don't have a mathematical model. They can't actually solve this one, even if this model has, the real hole in the soil was even worse, of course, because it was on sharp and so on. But they don't have a mathematical model for solving this one. So we had this discussion in the class. We made it so that now we'll just calculate for 10-15 minutes. Each one of you will come up with the method that you think will bring you the closest. Then we will write all the results of the blackboard or the whiteboard, and then we will see how different results we have. What is the tolerance? What is the plus minus here? And that was some cubic meters. They did it in very different ways. Some of them used the average of the depth. Some of them used the average of the two trapezes. Some of them found a trapeze in the middle. Some of them cut it into different pieces and so on. And they had different results. And we had this, and they had to argue for the other ones. I told each student, convince the rest of the students in the class and me that your calculation is the most precise. They so much wanted me to tell who had the most precise calculation, and I didn't. I just said, convince the rest of us that yours is the most precise one. And there was a lot of discussion about that. And we also had this discussion, well, how close will we have to come with a mathematical result in order to have solved the practical problem? Is it plus minus a spoonful? Is it plus minus a bucket? Is it plus minus a wheelbarrow? And what will that be in cubic meters? So always these discussions trying to link the real life problem with the mathematics when the mathematics cannot solve the real life problem precisely. That was a very interesting thing. Actually, one of them had cut it up in 3 pieces and they asked, will that be more precise than calculating 1? Yes. And we have this question, the more pieces you cut it up in, the more precise will your answer be. And then one of them said, if I go and make a spreadsheet that can divide it into 3 pieces, and when I've done that and the spreadsheet works and calculates correctly, then I can change 3 into a fantasillion, and then I will be very, very specific. Ain't that wonderful? I mean, students at a very low level. I would brag if I said that we have found the perfect way of teaching. We had loads of different problems also in this way of working. We had to we took the students out of their comfort zone, and we had to work with that to make them comfortable with working this way around. So, but what we found was that we teachers believe, and also the one who did the study, that we actually achieved a better understanding of mathematics. They might not do better at the test, but they might remember afterwards better what they learned. Their practical teacher said that they did bring the teaching more to the workshop and started to calculate when they had to solve their practical problems. The students told us that they found the content of the lessons more meaningful than normally with maths. We saw that we had more active students. We had less students looking out of the window. I would lie if I say that we didn't find students who spoke with each other about everything else than maths. But we did find a high degree of activity among the students, also the activity that we wanted. We had far more communication. They talked and talked far more about mathematics than they usually do. And then we had 2 unplanned side effects by lucky punch. Point 1. The teaching kind of did its own differentiation, because we had some very low achieving students in the classroom. We were quite afraid, will they be able to take part in that? And they were, except but one, because they just found and saw mathematical problems that were quite easy to calculate. Small ones, easier ones, so they all did contribute on their own level, kind of. It leveled for each student automatically. We hadn't foreseen that, and we hadn't planned that. The last thing that came up that we hadn't planned was that the program revealed misconception among the students that we wouldn't have dreamed of. For example, 2 students we discovered that had to measure the height of a door. They would find the area of a wall minus a door, and they had to calculate the height, to measure the height of a door. They measured from the ceiling to the upper side of the door. I would never have identified that misconception if it wasn't so that it came up there. I have more examples, but I won't have time for that. For example, that they have difficulties in measuring when the measuring doesn't go from the left to the right. You may have seen that also. They have learned that the number line goes from the left to the right, so they measure from the left to the right, but suddenly they might have to measure from the right to the left, the distance from that wall line out to the door, and they will have difficulties measuring when they turn the ruler upside down.